So in this video, we're going to have a look at rates of reaction in chemistry. So a quick introduction. So chemical reactions can be fast or they can be slow. Okay, I've got a couple of examples here. So if we mixed potassium iodide and lead nitrate, like in this picture here, we would get a yellow precipitate formed immediately. So this is a very fast reaction. Other reactions are much slower. For example, this painting here, you can see the colours of the grass and the trees have gone sort of a brown colour, and that's taken hundreds of years to take place. So that's an example of a slow reaction. When we're looking at how fast a reaction goes, what we're really looking at is the rate of the reaction. Okay, so that's the rate of reaction is the speed at which a reaction takes place. In terms of how we measure a rate of reaction, okay, we can do an experiment like the one we've got a picture of here. This one is marble chips with hydrochloric acid, and when they react together, they produce carbon dioxide. So what's happening in the picture is that the volume of the carbon dioxide is being measured in a measuring cylinder. Okay, so what are we doing there? We've got to look at actually how fast a reactant is being used up. So that could have been the mass of the marble chips or the concentration of the acid, or how quickly a product is being formed. So in this case, we've chosen to measure how quickly carbon dioxide is formed using that volume in the measuring cylinder. Okay, and we've got the results here. Okay, so the results of the reaction, the results of the experiment showing that over time, every 10 seconds, we've monitored the volume of carbon dioxide that's being collected. Okay, and that's the volume from the measuring cylinder. We can plot those results in a graph, and we would get something like this for that experiment. Okay, so we've got the blue line, you can see the crosses on there are the measurements that we took, and then we've done a line to join those up. If we want to calculate the average rate for this experiment, the mean rate, then we'd have to look at the total volume that's been formed. So in this case, it's 73 centimeters cubed of carbon dioxide. We divide that by the time it took to do that, okay? And that was in 40 seconds. So at 40 seconds, we've got 73 centimeters cubed of carbon dioxide formed. Divide that by 40, gives us a rate of reaction of 1.8 centimeters cubed per second. And if we want to think about why this is a rate, we can think about it like the speed of a car. The speed of a car, we'd be looking at the distance traveled divided by the time taken, so meters per second or miles per hour. In this one, we're looking at the volume of gas produced divided by the time taken, so this one is centimeters cubed per second. You can also see on the graph that the gradient of the graph gradually gets less steep. Okay, it's fastest at the beginning, so that's when the reaction is fastest, and then it gradually slows down. And when we get to about 46 seconds on the graph is horizontal, which means that the reaction has stopped. The last thing to mention about rates of reaction for now is that we can change the rate of a reaction. Okay, so there are various different factors that we can do or we can use to change the rate of a reaction. To think about that, in terms of any chemical reaction, particles will only react with each other if they collide with each other. Okay, so they can only react if they collide. If they collide harder or with more energy, then they're more likely to react. If they collide more frequently, then more particles will react. So we can make the reaction faster by either giving the particles more energy to make them collide more with more energy, or to collide harder, or we can get them to collide more frequently. Now the picture that we've got on this slide shows two examples. The one on the left is a lump of solid, a big lump of one lump of solid, and the one on the right is that solid, the blue particles, broken down into smaller pieces. By breaking the particles down, we've increased the surface area of the solid. And that means that we've got an increased surface area to volume ratio, and it means that there are more surfaces for the particles to collide. Okay, there's more surface for collisions to occur on, and so we get more frequent collisions, and so the reaction goes faster. So it's just one example of something that we can change about a reaction to make it work more quickly. So just to summarize what we've said in this short video, 1, reactions can be fast or slow. The rate of reaction is how quickly a reaction takes place, the speed of the reaction. We can measure the rate of a reaction by looking at how quickly a reactant is used up or how quickly a product is formed. We can calculate the rate of a reaction by dividing the amount of product formed or the amount of reactant used by the time taken. And we can increase the rate of a reaction by increasing the frequency and energy of collisions. And solids with a higher surface area to volume ratio will react more quickly.